Hello, today we've got the Roland SH-101 that's come in for a fix, bit of a repair. This is the grey one, obviously. They also made them in blue and they made them in red. I know you've seen on the internet white ones and yellow ones as well, but as far as I'm aware, Roland only made grey, red and blue. So the other ones are just very, very clever paint jobs. Now then, this is a lovely monophonic keyboard, and yeah, it's quite a classic keyboard. I think they're going to emulate the 101 in the new Aira system one. So yeah, it'll be bringing it back again. Well, in a way. Now, the problem on this, nice simple problem. Well, it's a simple problem until I open it up. I mean, I haven't got a clue what is going to be wrong with it, but dead key. So let's open it up, have a look inside at some of this wonderful vintage technology, and yeah, see if we can fix it. I don't know if I mentioned that these were manufactured from 1982 to 1986. So these have one oscillator. There's three simultaneous waveforms. There's like an octave divides the square sub oscillator, blah 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 blah. There's triangle, there's square pulse wave modulation waveforms, low pass filter, VCF. It's capable of self oscillation as well. But there's lots and lots of people on YouTube who do some fantastic demos of this, and I'm not a person to demo it. I'm a person to take it apart. So, screw all the time. I met her in a supermarket and I don't know any of the words. Alright, put a couple of bits of nice sponge down here because it's not mine, doesn't belong to me, it's for repair. So, onto the back, and there's a screw missing already in the corner here, and you'll also notice actually there's two little screw holes over here. And the good thing about these, just changing the subject again, is that you used to be able to plug a controller in here and then put it onto a guitar strap, and this was used as a keytar, and on the controller you could control the modulation and things, and you know, wear it over your shoulder and get on the stage up front. But anyway, let's stop rabbiting and get it open. Okay, all the screws are out, very easy to remove. The bottom plate is made of metal and there's nothing connected to that. Oh, there's a bit of 30-odd-year-old muck in there. Give that a little clean. Put that to one side. And here is your SH-101. Very nice. So, let's get this keyboard section off. No, it was the B flat. So, remove the little spring here. Just here there's a plastic clear strip running across the back. Just here where I'm putting my screwdriver underneath. Now if we slightly lift that, we can slide the key forward. So, and that's how you remove the key. These are little rubber plungers that push down onto the board. Now this, where your B flat is, it is actually sticking up slightly. So that means crap and crud can go down there. It's not sealed properly because it's overlapping the next one. So we need to carefully peel that up and give it a good clean underneath and pop it back on so that it sits flat like so. On the actual carbon contacts there, you can see it's been scraped and scratched with a screwdriver to try and make it more active. So somebody's already been here before me. Right, okay, so today I'm fixing somebody else's temporary job, I believe. Now the carbon contacts on these horrible little rubber plungers are quite badly worn and quite dirty as well, because one of them's been lifted up for a while. Somebody's cleaned them in the past and it hasn't quite gone back down correctly, so crap has built up over time, and you know, it doesn't help. It's very dirty, so I'm going to clean these up anyway. Now the carbon contacts on here, what happens is when this goes down, it bridges the carbon contacts there, and that's how the keyboard knows that key has been activated. Now these have been scraped with screwdrivers and things to try and clean them up. That's not always the best way to do this. Somebody has also gone over it with the pencil idea and actually got pencil in between them. So there's a very slight resistance across that all the time. So what I'm going to do, I'm just going to use a bit of this compact disc cleaning solution. It's isopropyl alcohol. A little tiny bit on a cotton bud or a Q-tip for my American viewers. Cotton buds in England, Q-tips in the USA. And I'll put a little bit on here, and I'm going to clean these up and try and trim this piece of plastic. Take a very thin slither off the edge here, so hopefully it'll go down and seal the gap. Then I'm going to pop it back into there and see if it works. If it works, fine, brilliant. If not, I'm going to have to do a temporary fix and get a very soft pencil and just draw in the soft pencil. That has a resistance, and it'll keep it working for a little while, but it's, you know, it's not the ideal fix, unfortunately. It's only a temporary, but this might work if I clean this up. So let's have a go at that first, shall we? Oh, slice of lemon with that, very nice on a hot sunny day. Right, okay, so let me clean these up.
Don't forget the umbrella.
Yeah, isopropyl alcohol with a little umbrella sticking out the top of it. Very nice. Now what I need to do is very slightly just skim the edge here, so this can sit back down there. I'm going to drop this back into there, and then we'll fire it up. See what happens. Okay, so we didn't fix the fault there. Oh well, that didn't work, so I'm going to lift this back up again and see if I can try just scraping a tiny bit of a layer off the carbon. Now, to do the rubber plungers, I'm going to attempt, these are the cut-off discs for Dremels. So if I get one of these, it's quite a fine surface, and if I just poke through one of these little carbon discs and just rub it gently on the surface there, it might be enough just to clean off the old crap. And make good the carbon underneath again. Just nice and gently, I don't want to overdo it. Okay, I've put the bottom back on. I've not bothered screwing all the bottom on yet because I'm possibly going to have to take it apart again. Well, I hope not. But we've always got the temporary pencil fix. And there's plenty of people on YouTube that sort of show that fix, and it does last for a little while. But let's see. No, right here. Yes, it's done it. So now we can have time to actually turn it over and just have a look what's actually in this thing. Fix done at last. Looking at the board, the Roland synthesizer SH-101, which is proudly printed in white lettering on one side of the board there. I don't know what this is. Ugh. Oh, it's just a bit of sticky tape. Gone old. I think that's actually papyrus. Never mind. Right, okay. So we've got a few monolithic chips there. They're the dual low noise op amps. There's some more little op amps here and things. This Toshiba chip, the 80C49P6, that's got 2K of memory on board, and it's an 8-bit microcontroller or processor. 128 bytes of RAM and 2K of ROM, and yes, that does all lots of nice bits of magic and things. And then, right, moving along, we've got some Hitachi ports. Oh look, well no, just point out, sharp, 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 Toshiba, Hitachi, Toshiba, Hitachi, CEM, loads of different makes. In fact, the only chip on here is this Roland IR-3109. Now that's a 24 dB low pass filter. They use the same one in the MC202. The Jupiter 6 and the Jupiter 8, I think, uses these as 12 dB filters. The Juno 6, the Juno 60, the JX3P, the MKS 80. So that's quite a common chip in a lot of Roland parts. Now back to this CEM chip here. This is one of them Curtis chips. It's a self-contained voltage-controlled oscillator. There's 4 sort of buffered output waveforms on that. Triangle, sawtooth, square wave, pulse width with voltage controllable pulse widths, and yeah, that's used in a lot of stuff as well. They're in the Crewmore. There's 2 of them in the Crewmore Spirit. The Prophet 10 and the Prophet 600 had it, and the Jupiter 6 has actually got 12 of these inside it. So yeah, this only uses 1. Very nice. Looking back, no, nothing terribly exciting, just lots of little op amps here, there and everywhere. There's a lot of interesting variable resistors, VCO width, VCO tune. This is where something would have gone, the VCA offset, but there's nothing there. But yeah, little pots and things everywhere. I don't turn anything. I've no need to turn anything. I fixed the keys, so now this little baby's going to work. But yeah, there's, well, there you go. That's basically all your synth. Very nice. It's a pity they didn't put some of these pots on the other side though, so you could have a little bit more control. Anyway, I'm going to flip it over and I'm going to screw the back down onto this. Like I say, some of these little holes where the screws go are split and have basically had it. I've got a tap and die set, but there's nowhere to go in any further. There's no more tube, no more space to go down any further. So I'll just put the screws in carefully and we'll flip it over and just check it one more time for the customer. Keep the customer happy. Alright, okay. Because a few times I think I've mended something and I get all happy about it and I screw it all back together and I plug it in and the problem's either come back or a new problem has arisen. So let's get this back together first, and then I want to try a little experiment with this next. So bear with me. Right, fingers crossed, legs crossed, power. Ooh, yeah, it works. Tasted like 9 volts AC, that. Right, sorry, I've just been a twat. Okay, let's make sure this works. Ooh, Now, the thing is, make sure it works instantly. Which it does. Brilliant. Okay. Oh, I've got another idea. Now this is fixed, I want to try something. As you know, these did not have MIDI. Pre-MIDI. These were made from 82 to 86. So yeah, MIDI started crawling in, I can't remember what year. But it does have a CV in, gate in, but it has the external clock in as well. Now if you can send a pulse signal to the external clock, then you can set up the speed of the arpeggio. Okay, so what I'm getting at is this. Just unplug that in a minute. If you wanted to use that with a bit of modern day equipment and you haven't got no MIDI, how are we going to do it? There's an idea. So the Roland SH-101 has the external clock input. Now the external clock input requires 5 volts. 5 volts to switch the clock on, down below switch the clock off, whatever. So I'm just wondering, I know it hasn't got no MIDI in, I'm wondering with one of these things, right, maybe with a snare drum or the high tom or something, you can assign to these assignable A's and B's on the back. I'm wondering what sort of voltage comes out of one of these. Maybe we can jack out of that and into that. Right, after getting my head together, I figured out I was doing something wrong here. I wasn't using this as the volume output for the bass drum, which I had eventually assigned to assignable A in here. It's not very clear in the instruction manual how to do that, but you know, have a look around the net, and other people have written the instructions that Roland should really have given in their leaflet that they sent out with this. Now then, this obviously now is going to be the voltage output, which is going into the clock input on the Roland SH-101. So if I set the drum machine running so it's not very musical and hold down 3 keys, now the clock is working with the arpeggio on here, and to show that I can turn up the tempo on the TR-8. And down again. So there you go. It is possible to clock an SH-101 from the TR-8 without MIDI. I hope that might be useful to some people. I don't know, maybe, maybe not. But anyway, it's just an experiment and it worked. So thanks for watching, and I'll see what I can get into next time. All the best.